Today let us see some examples on duality theorem or duality property of the Fourier transform, but also let us look at some few more examples on time shifting property of the Fourier transform. Let us start with the first example today. Okay. Here what is given is g of t is given as a sin 2wt. Now this is the function given to us. If you remember earlier we have seen that a rectangle t by t is having a Fourier transform which is equal to at sin ft. Okay. That means if you see this here, the Fourier transform in the frequency domain is a sinc function. What is the problem given? The problem given here is talking about a sinc function in time domain. So this is a perfect case of duality property. So what does duality property say? Let us first put down duality property. Okay. Okay, what does duality property say? G of t, if it is having a Fourier transform g of f, then g of t will have a Fourier transform g of minus f. Okay. So this is the duality property. Now applying this duality property and also identifying that there is a scaling factor here, I need also time scaling property here. So we also use time scaling property. So what does time scaling property say? Time scaling property says okay, time scaling property says what? G of t is having a function, this is equal to g of f, which is a Fourier transform. G of t is having a Fourier transform g of f. Then if the time is scaled by a factor a, then it will have a Fourier transform which is equal to 1 by mod a g of f by a. Okay. So what we will do is in this, to solve this problem, we have to take both these properties into consideration. One is the duality property and the second is time scaling property. Start, we say that we know a rectangle t by t is having a Fourier transform which is at sin ft. Okay. Now I had to find out what is the Fourier transform of this. So what is given for us? A sin 2wt will have a Fourier transform of what? That is what we have to see. Now using duality property, a sinc function in time domain will have a rectangular function in frequency domain. So let us write that first. So it is a rectangular function which is in f. Okay. Here this is the scaling factor 2w. Okay. A is there. So a is there and it is scaled by a factor 2w. So the Fourier transform of the function given a sin 2wt is a by 2w rectangle f by w. So what is the answer now? The answer is a by 2w rectangle f by 2w. So this is the answer for this question. Okay, let us see the second example. We have to calculate the Fourier transform of the given signal. So if you see, this is again a rectangular pulse. Earlier if you see, there is another rectangular function like this. Okay. We said this is minus t by 2, this is 0 and this is t by 2 and this is a. This is a rectangular function. What is the difference between these two? The difference is here, what is that we have done to this? We have shifted this by a factor t by 2 to the right. Okay. So when I shift this to the right, what happens? Then this function will be what is shown here. So it will be like this. So this is a function which is shifted in time by a factor t by 2 to the right hand side. So the property which we have to use here is the time shifting property of the Fourier transform. So what does time shifting property say? Okay, let us say time shifting property here. Okay, time shifting property says again g of t is having a Fourier transform g of f. Then if the g of t is shifted by a time factor t naught, then the equivalent Fourier transform will be g of f e to the power of minus j2 pi f t naught. That means, if a function is shifted in the time domain by a certain factor t naught, it will be equivalent to g of f, which is multiplied by a factor e to the power of minus j2 pi f t naught. That is, there is no change in the amplitude of the signal in the Fourier transform when you time shift it, but there will be a phase change that is given by e to the power of minus j2 pi f t naught. So, for us we have to apply this formula. For us, what is the t naught here? T naught is, for us here, it is t by 2. So, that is what has been shifted to the right hand side. Now, what will be the g of f? If you remember, what is the rectangular function? For rectangular function A, rectangle t by t, it is having a Fourier transform which is equal to at sinc ft. Yes. So, now what is it we have to do? Now, we have to calculate this minus j2 pi f t naught, because this does not change. So, how does what is the Fourier transform? Now, let us write it here. So, at sinc ft, okay, e to the power of minus j 2 pi f into t by 2. So, this will get cancelled. So, you will get this like this, at sinc ft e to the power of minus j pi f t. That means, if a rectangular function is shifted to the right hand side by a factor t by 2, then you will get this function, and the Fourier transform of this will be at sinc ft e to the power of minus j pi f t. So, this is the answer for a function which is shifted to the right hand side. Similarly, we will see a next example where the function is shifted to the left hand side by a factor t by 2. Let us calculate the Fourier transform of a function. Let us say g of t, and g of t is given like this. So, we have to calculate the Fourier transform of this. So, actually, if you look at the rectangular function which you have seen earlier, now it has been shifted left hand side by a factor t by 2. That means, it is shifted by a factor minus t by 2. So, we will get this type of function. Now, let us apply again the time shifting property of Fourier transform and find out this directly. So, using time shifting property, okay, what is it? What does it say? G of t minus t naught will have g of f e to the power of minus j2 pi f t naught. So, this is what is the t naught here? T naught for us is here minus t by 2, because this is shifted this side, left hand side. So, a function, a rectangle, recognizing this recognizing this as a rectangular function. What is the Fourier transform of this? We already calculated this. So, this will be at sinc function of f t. Now, for us this is shifted, isn't it? So, this answer will be at sinc, okay, f t, okay, when this is shifted by a factor, when shifted, okay, when shifted, what should be g of f? G of f will be at sinc f t, then exponential of minus j2 pi f into minus t by 2. So, this will be equal to at sinc f t exponential of j pi f t. So, this is the answer. Okay, so, the answer is this. Now, we are making use of the identities which we already know. That means, already we have calculated what is the Fourier transform of a rectangular function. Now, if the rectangular function is shifted to the right hand side or to the left hand side by what factor? So, whenever there is a change in the time scale, then we have to use the time shifting property. So, it is shifted by a certain time. in this problem, what is the time shift? It is shifted to the left hand side by a factor of minus t by 2. So, it will become a left handed side function which is rectangular. Now, that we have taken care here, and then just we have used the formula here. We already know what is g of f. So, we have just multiplied it, so j pi f t. So, if you compare this problem with the earlier problem it is a right shift function by t by 2. So, this is exponential minus j pi f t, and if it is shifted to the left hand side by a factor minus t by 2, it will be a j pi f t. Now, this example says we have to calculate the Fourier transform of g of t. So, this is g of t for us. Okay. So, as you recognize, this is again a rectangular function, but the fact is this has been shifted to the left hand side by a t by 2. So, this is left-handed shifted function. So, this is a left-handed sided rectangular function. Now, we know that time shifting property says g of t minus t0 is equal to g of f e to the power of minus j2 pi f t t naught. That is, the amplitude remains same, whereas the phase angle is changing, right. Now, for us, what is the shift here? T naught is minus t by 2, because this is shifted to the left hand side. Now, recognizing that this is a rectangular function, earlier we have seen the formula for rectangular function. What does it say? It says this is centered around the origin, isn't it? So, this rectangular function says a rectangle t by t is having a Fourier transform a t sinc f t. Now, this is g of f. We know what is g of f. So, g of f is understood. So, I have put g of f here. Now, after shifting, what is the formula? It says we have to multiply this by minus j2 pi f t t. So, we have done that, and then I got g of f, which is equal to a t sinc f t, that is g of f remains as it is, whereas this is getting multiplied by e to the power of j pi f t. So, if you compare this problem with the earlier problem, earlier it is a right hand side function, this is minus j pi f t, this is the left hand side function. So, this will be plus j pi f t. Okay? Let us look at the next example. This example is this, where g of t is given as a rectangle t by t multiplied by cos 2 pi f c t. So, this example is a rectangle t by t and then cos 2 pi f c t. Now, here if you see, the rectangular function is getting multiplied by a cosine function. So, how does this figure look like? So, let us just draw the figure. Okay, so, let us say these are my limits of the rectangular function here. So, what should be that? That should be t by 2 here and t by 2 here. So, there will be a cosine function here, okay, of a certain amplitude here. Okay. So, this is what we have to find out. And now, this can be called a RF function if the frequency is very high. So, if they move they move very close to each other, then this becomes a radio frequency function. But that is a different story altogether. But let us find out what is the Fourier transform of this function. Now, how to solve this? Let us first, we also know what is cos 2 pi f c t. Cos 2 pi f c t in fact can be written in terms of exponential functions. So, let us say, okay, we know that, okay, cos 2 pi f c t can be written in terms of exponential components, that is half exponential of j2 pi f c t plus e to the power of minus j2 pi f c t. Okay. This is the cosine function equivalent. Now, if we put these two together, what will be g of t? G of t will be equal to a rectangle t by t, okay, into 1 by 2 of e to the power of j2 pi f c t plus e to the power of minus j2 pi f c t. Now, we have to get the Fourier transform of this, that is g of f. So, if you see here, the rectangular function is getting multiplied by e to the power of j2 pi f c t once, and then e to the power of minus j2 pi f c t second time, of course, scaled by a factor 1 by 2. So, now we have to identify which property we have to use here. If you look at Fourier transforms, there is one property called as a frequency shifting property. Frequency shifting property. So, what does frequency shifting property says? It says when there is a shift in frequency from f to fc, then the equivalent time domain will be multiplied by a factor j2 pi f c t g of t. That means, when the frequency is shifted from f is equal to 0 to f is equal to f c, then the equivalent time domain representation will be multiplied by a factor e to the power of j 2 pi f c t. Now, this is a perfect case. If you look at this here in our example, g of t, let us say, is a rectangle t, that is g of t is a rectangular t by t for us here, and then it is getting multiplied by a to the power of j 2 pi f c t here, is it not? So, we can use this frequency shifting property and find out what is the Fourier transform of this. So, let us do that now. Now, let us calculate what is g of f. G of f will be g of f minus f c in these cases. So, a rectangle t by t, what is the Fourier transform of a rectangle t by t? A rectangle t by t will have a Fourier transform which is equal to a sinc at sinc ft. So, this is the Fourier transform of our rectangular function. So, we will use that here, and then with that, what is it? I have to take care of the frequency shifting which is happening because of the exponential multiplication here. So, let us write down here, because a 1 by 2 is common here. So, I can write this as a t by 2, okay, sinc of the first function is getting multiplied by a to the power of g to pi f c t, that is, it must be g of f minus v. So, it will be sinc of t into f minus f c, okay. Why this is f minus f c? Because this is the first factor is getting multiplied by a to the power of j to pi f c t, it is getting multiplied by e to the power of j to pi f c t. So, it will be shifted by a frequency f is equal to f c. Now, what is the second component here? Second component, it is shifted by minus j to pi f c t. So, when this becomes f c, that means f is equal to minus f t, that means if your spectrum is shifted to the left hand side, then the time domain will be multiplied by e to the power of minus j to pi f c t. So, what will be the answer here? Here it will be sinc of, okay, t into f plus f c. So, this is our g of f. So, what is it we have done here? We have taken use of the frequency shifting property. That means, whenever the frequency domain there is a shift in frequency, it will be equivalently multiplied by an exponential function j to the power of 2 pi f c t, the time domain function. Now, we have given a g of t, we have already identified this. So, this is at sinc f t, that is which we have put here, and then the 2 we have taken here. So, it will be at by 2 sinc of t of f minus f c plus sinc of t of f plus f c. So, this is a function which is getting multiplied e to the power of j to pi f c t, and this is a function which is getting multiplied by e to the power of minus j to pi f c t. So, this is how it looks. So, what does it say? Whenever a function is exponentially multiplied in the time domain, then we will get a function which is shifted in the frequency domain by a factor equal to f c on both sides. Now, let us draw the amplitude spectrum of this. Okay, let us take this. So, here I am taking this as origin, and this is the amplitude spectrum. So, g of f. So, this is our g of f, right. So, now let us identify two frequencies here. Let us say this is my one frequency and this is my negative frequency, this is minus f c. If you see here, both are sinc functions. So, similarly here, and these are scaled by a factor 1 by 2 on both sides. So, this is the amplitude spectrum. So, if you remember, the earlier we have drawn the g of t function, that is a rectangular function which is cosine function limited to a factor minus t by 2. When we take the Fourier transform of that, I will get two sinc functions which are distributed like this. So, this is the frequency spectrum of the given problem.